Welcome. Today we are discussing Archimedes Principle. This principle is named after the renowned ancient Greek mathematician, physicist, and engineer, Archimedes of Syracuse. Archimedes' principle is a fundamental concept in fluid mechanics that explains the behavior of objects immersed in fluids. Definition of Archimedes' principle. Archimedes' principle states that when an object is partially or wholly immersed in a fluid, it experiences an upward buoyant force equal to the weight of the fluid it displaces. In simpler terms, this principle tells us that any object submerged in a fluid will experience an upward force, also known as buoyancy, which opposes the gravitational force pulling the object downward. Let we lower a wooden block into container of water. As the block sinks, it continuously displaces water. As the block sinks deeper, displacing more water, and so the magnitude of the buoyant force increases. At some specific point the buoyant force becomes equal to the weight of the block. At this point the volume of displaced water is equivalent to the volume of the wooden block. Two forces act on the block. One is its weight acting downward, another is the buoyant force acting upward. The two forces balance each other. Weight of the object W equals m naught g and buoyant force Fb equals weight of the displaced fluid. Fb equals W, displaced water. As density equals mass per unit volume. Mass equals density multiply by volume. So W equals density of the object, volume of the object, and gravitational acceleration. Equation 1. Fb equals density of the fluid, volume of the fluid, and gravitational acceleration. Equation 2. Dividing equation 1 by equation 2. As volume of displaced fluid is equal to the volume of object immersed, so volume of the object equals volume of the fluid displaced. Thus the ration of weight and buoyant force equals the ratio of densities of object and fluid. When we put blocks of different densities on water surface, their behavior is different. The foam floats on surface of water, the brick sinks, and the wooden block floats under the surface of water. When the density of the body is greater than the density of the liquid, the body sinks, and when the density of the body is less than the density of the liquid, the body floats. And when both densities are equal, the body floats below the surface of the water. Now we perform a simple activity to demonstrate the Archimedes principle. We take a body of mass 200 grams. And attached an empty bucket with it and measure the weight attached by means of a spring balance, which is 3 newtons. Now we slowly dip the body in the beaker filled with water. You see, as the body sinks, its weight decreases. And when the body goes completely underwater, its weight decreases nearly to 2 newtons. As much water as the body removes from its place, we collect it in a beaker. And when we pour this water into the bucket, the spring balance shows us the weight of the body before immersion. Hence, it is proved that when a body is immersed in a liquid, its weight is reduced by the weight of the displaced liquid. That is, an upward force acting on it which is equal to the weight of the liquid displaced is called upthrust or buoyancy force. Now we look at the fluid removed and the reduction in body mass using a digital balance. As we submerge the body, it displaces the liquid from its place. And the weight of the body decreases, which is equal to the weight of liquid displaced. When a body is completely submerged, the sum of both the weights of the body and the weight of the liquid displaced is equal to the weight of the body outside the liquid. Archimedes' principle has several significant applications and implications, making it an essential concept in various fields, including physics, engineering, and everyday life. Archimedes' principle helps us understand why certain objects float while others sink in fluids. It provides the basis for designing ships, submarines, and other floating structures. For example, a ship that is launched sinks into the ocean until the weight of the water it displaces is just equal to its own weight. As the ship is loaded, it sinks deeper, displacing more water, and so the magnitude of the buoyant force continuously matches the weight of the ship and its cargo. Hope you will understand Archimedes' principle well. Thanks for watching.